Chi-square test in SAS. Introduction. The chi-square test is a powerful statistical tool used to determine if there is a significant relationship between two categorical variables. This introductory section provides an overview of the key aspects and applications of the chi-square test. So it is very essential to ensure that you first get the two categorical variables. So we need 2 cross 2 contingency table to get the relationship of the two variables, right? Importing data into SAS. Data source. The first step is to import the relevant data into SAS. This can be done by connecting to a database, reading a CSV file, or using other data input methods supported by SAS. So the first step is to ensure that you have a relevant database. It could be in CSV, Excel file, or XPT file. So converting that XPT file to SAS dataset, and then you can use your analysis. So the first step is to get the data from specific, here the database. Data structure. Understand the structure of the data, including the variables, data types, and any missing values that will help ensure the properly formatted for the analysis. So very first thing is you understand the data before doing even analysis, or before even performing or choosing any statistical test or statistical tools. It is very essential for a programmer or a statistician or for an analyst to ensure that they understand the structure of the data. You really need to understand the data first, then pick up what kind of variables you need, then see what are the different types of data, and if there are any missing values, you raise issues or you raise queries, and then you can do the analysis. So that will help you in getting the data in formatted way. Data exploration. Explore the data using SAS functions and procedures to get a better understanding of distribution patterns and relationships between the data. So you can use various procedures, you can use various SAS functions so that you can understand the relationships between the variables in the specific data set. Exploring the data, variable distributions. Analyze the frequency distributions and summarize statistics of the variables involved in the chi-square test. So if you want to understand the data properly, the first thing is you need to dig into the structure of data. Now once you have understood the structure of data, then once you have understood the importing it from the database, the next thing is to analyze the summary statistics. Like say for example, how many patients I'm having for improved cases and how many patients I'm having with not improved cases. What is the mean value of improved cases, or what is the mean value of not improved cases? So these statistics will also help you in some way or the other before applying the chi-square test. Cross tabulations. Create cross tabulations to examine the relationship between the variables of interest. So what happens is you are creating 2 cross 2 contingency table to understand the interest. Visualization. Use SAS visualization tools to create charts and graphs that help further explore the data patterns. So for example, if you want to understand how the data is going or what is the pattern of the data, so you can perform the various charts, like say pie chart is there, histogram is there, you can even perform the scatter plot, or you can even perform the line graph, whether the values are going up or down, or whether it is completely spread it across all the different values of x-axis and y-axis. So these charts and graphs, it will help you in understanding the pattern of data. Preparing the data for analysis. Data cleaning. Address any issues with the data such as missing values, outliers, inconsistency, to ensure the analysis is based on high quality. Now why it is essential to remove such outliers? Because like say for example, I am having a very weird number of an efficacy primary endpoint value as same, it should not be more than 10. Now the outlier value is 20 for one particular record. So when you do the summary statistics or when you do the chi-square test, the effect of this weird number or the outlier will impact the analysis, because the outlier value, it indirectly impacts your value of chi-square test statistic, then it falls and it implies into the p-value is affected, and from that p-value your interpretation also it could be wrong. So it's very essential that you ensure that there are no missing values. So you raise the different queries or questions to the monitoring team, then you check for any outliers. Now there are various methods also for which you can use the outliers, like say box and whisker plot is there, or this inconsistencies also you can remove. Variable recoding. Recode or transform variables as needed to meet the assumptions of the chi-square test, such as combining categories or creating binary variables. So you can always create binary variables, like say I'm having value yes and no. So I can use 1 or 0 if I want to perform any counts or percentages, like that. So you can even create binary variables as well. Data subsetting. Select the relevant subset of the data that will be used in chi-square test based on the research question and study design. So if you want to perform this chi-square test, you can even select the relevant data. So say for example, I need only these many patients that fall under that specific category. So that will be the subset of data. So I will be using the chi-square test only on that subset question. So it is very essential that first you understand what is the research question, right? And then you understand the design, and then you perform the static chi-square test. Performing the chi-square test. Null and alternate hypothesis. So you need to clearly define the null and alternative hypothesis for the chi-square test based on the research question and the variables interest. So whether, say for example, whether I want to reduce the value or whether I want to increase the value for that specific, whether the treatment improves or decreases. So first you need to understand from the medical point of view what is the significance of that primary endpoint from the medical point of view. Once you have understood the medical point of view from doctors and physicists, then you can clearly define the null and alternative hypothesis from statistics point of view. So it is very essential that you understand the variables of interest, which are the two variables important, so that I can understand the association between the two variables, and that would impact the analysis, and that will explore that the treatment has improved. Test calculation. Use the appropriate SAS procedure. So you can use proc frag, proc logistic. You calculate chi-square test and associate the p-value. Statistical significance. You can interpret the p-value to determine if the results are statistically significant, if the null hypothesis can be rejected. So it is very essential that you come to the conclusion once you have performed your p-value. Interpreting the chi-square test results. Evaluate the magnitude of the effect size as measured by the chi-square test to determine the practical significance of the findings. Strength of association. Assess the strength of the association between categorical variables using methods such as Cramer's V or phi coefficient. Contextual interpretation. Interpret the results of the chi-square test in context of the research question, the study design, and the theoretical framework. So once you have understood the research question, once you have understood the study design, once you have understood what kind of theory it is, only then you will be able to interpret the results. You will be able to find out the association between the two results, and that's how you will be able to get the magnitude of the effect size. Assumptions and limitations. Ensure that the data meets assumptions of chi-square test, whatever it could be, the independence or the sample size or the expected cell frequencies C's, right? So say for example, if the frequency of each cell count is less than 5, like one of the cell count is less than 5, so in that case I will use the Fisher's exact test. I will not use the chi-square test. So you need to understand the assumptions of the chi-square test. Limitations such as sensitivity to sample size or potential confounding variables to influence the result. So you need to understand whether the data is sensitive, whether we should apply or we should not apply. So first you need to understand the data pattern, the data variability, and then the sensitivity of the sample size. Robustness. Explore alternative statistical tests or techniques that may be more appropriate if the assumptions of the chi-square test are not met. So say for example, if the assumptions of chi-square test is not met, then you can explore other possible tests. Now say for example, I just recently said that if the cell count is less than 5, then you use Fisher's exact test. So that means it is not meeting the assumptions of the chi-square test. So I will go for the Fisher's exact test. Likewise, you may have so many other alternative tests if you are not able to fit into the chi-square test. Visualizing the results. Create bar charts, stack bar charts to visualize the observed and expected frequencies for the variables involved in the chi-square test. So these observed and the expected cases that will help you in visualizing the data if you present in the bar charts. Mosaic plots to graphically depict the relationships between the categorical variables and the strength of association. So you can use such kind of plots to understand its association. Applying to real world scenarios. Use the chi-square test to investigate the relationship between the customer demographics and purchase behavior. So you can use this in marketing. Healthcare, where you need to assess the association between risk factors and disease factors or from the medical intervention point. So you can use in the healthcare sector. Education. Employ the chi-square test to explore the relationship between student characteristics and academic performance or education like outcomes. So you can also use in the education field. So these are the certain real world scenarios where you can use the chi-square test, and it is not limited to any specific therapeutic area or any therapeutic disease that I should use this chi-square test only in this specific test. No, you can use in any therapeutic area and any therapeutic disease provided that data pattern is following and meeting the assumptions of chi-square test and it does not have any limitations of chi-square test. Conclusion and key takeaways. The chi-square test is a versatile statistical tool for analyzing the relationship between categorical variables. It can apply in a wide range of research and business context, right? Key takeaways. Ensure data quality, understand the assumptions, interpret the results carefully, leverage visualization techniques and effectively communicate the findings. Explore more advanced techniques such as logistic regression, log linear analysis to further investigate the relationship between variables. Now, chi-square test is not the only one statistical tool or test available to check the relationship between the two variables. So there are various other techniques, logistic regression, log linear regression, Fisher's exact test, so there are various regression analysis models also you can use to further investigate their pattern of data and the association. Please like, share and subscribe. Leave a feedback comment mentioning any topic that you want me to make a video. Looking forward for a positive response. Thanks for watching. Please like, share and subscribe. Leave a feedback comment. Many thanks for your support and having great connection.